So we're back in Satisfactory, working on the nuclear power plant here. In the previous recording, which had a lot of editor windows popping up over it, I managed to describe what was going on, but let's do a quick review. We have a bunch of machines, a bunch of constructors making silica, and we are merging that with the silica byproduct from over across the factory. And that's done with these mechanisms where we take the low quantity, high priority mixture coming in the bottom, we split it and merge it with the top. So if both of these belts were completely full, the output of the top merger would be 2 parts from below and 1 part from above. So 2/3 of a belt from below, 1/3 of the belt from above. And the bottom belt would have 1/3 of a belt. And the second stage, I've actually built this before I did the math properly. The second stage would take we'd have the 1/3 from the bottom. The remaining third, the part that didn't get selected by the guy on the top, would overflow out the bottom. It's a smart splitter. So this preferentially says send it out the left and the right and overflow there. So we're getting 2/3 bottom and 1/3 top because this top one is fairly selecting among its inputs. So this guy is now going to see its input here, which is 2/3 from the original, 2/3 from the original bottom and 1/3 from the original top. And the other two, oh, thank you, autosave, your timing is perfect. The other two inputs come from below, which is another smart splitter. Well, the splitter below has 1/3 of a belt coming in, so it's sending 1/6 of a belt up each side. So this guy at top sees 1/6 of a belt on the right and 1/6 of a belt on the left, and a full belt coming in there. And it tries to fairly merge, so it ends up taking all of the left and all of the right and most of the top. So if the two inputs were both full and the output was draining at speed, our output here would be all from below. Okay, so we would have drained the below completely, I believe. Yeah. And it may flow back and forth because when this is taking here, this will only be taking 2/3 of a belt from here, which would mean, well, the math gets weird. Anyway, the reason why I used 3 was, first of all, I didn't do the math at all. I just said, well, this guy's going to be 1/3 from the top and 2/3 from the bottom, so I'll just do it 3 times, and the bottom will have a 27th. But anyway, if the output backs up, which we need to handle, what happens to the bottom? Well, the bottom, we've got stuff coming in, it gets split, and it can't send any up, and it gets split, can't send any up, gets split, can't send any up, and the overflow goes into the sink. So we will never back up this belt. And on our output, we will have all of what was on our input belt, if we're not sinking, plus enough from this belt to fill it in. So this belt can pack up. We're allowing that because that's fresh construction of silica. We don't need to keep that going. If it backs up, it's okay. And in the end, we have our 2 lines of silica, each of which is over half full, and they head out across the world to be chewed up over here by our sinks. These sinks are representing, they're saying that the materials coming into them are destined for use further in the factory, and we're not there yet, so it's going to keep chewing on them. That way, all of our machines keep running, and I can spot check my performance by checking those machines and making sure that they are running at full flat out, whatever they should be running at, which is usually 100% given their overclocks. So that's the silica. Our next step is Caterium processing. And I'm going to show you the math on the Caterium, and I hope I remember to turn off the editor window when I'm done. So here is the full build for Caterium. We need a absolute massive amount of quick wire. We need 3,200 quick wire total, of which 1,400 is going to go into making AI limiters. And the AI limiters then go into making electromagnetic control rods. This is a huge build if you look at it all in one piece. So I thought, how can I divide this down? I thought, well, what if I cut it in 4 pieces? Well, first I thought 2, and then 4. I finally decided to cut it into 8 pieces. So that's about 2 assemblers on fused quick wire and 1 AI limiter and 1 electromagnetic control rod. That fits in a blueprint. So now we go to the part. This is 1 of 8 parts. I further realized that I could use 1 assembler making the quick wire for the limiters, because it only needs 175. And our actual output is 225, which is a quick wire machine just running flat out. So that worked out perfectly. And so we have fused quick wire feeding the limiters feeding the control rods, and we have the output is the control rods and the quick wire from the second quick wire machine. Turn off the Emacs window in OBS. There we go. So I started working on the blueprint, and I actually had recorded putting this blueprint together. And the whole recording was A, behind an editor window in OBS, so you couldn't see it, and B, my microphone was muted, so you couldn't hear me describing it. But here's what we do. This first assembler is making the quick wire for export. So zoop, and it goes up and out. The second assembler is making the quick wire for the AI limiters. So it makes it, and it jumps up and over and back down into the next assembler. The third assembler makes the AI limiters, whose output jumps up and over a little bit and back down into the final assembler, makes our control rods. And then they go zoop and up. So we have our 4 inputs here and our 2 outputs there. And we need 8 copies of this. Furthermore, some of our inputs are going to come in and stripe across, so we'll have 1 input belt that's going to feed 4 of these horizontally. And our outputs, one of our outputs is going to be gathered up horizontally, so 4 of them will be on one belt and 4 on the other. And the other output is the quick wire, which is 225 per. So I will have 2 of these east-west pulling, going into a belt. So we'll end up with 4 belts of quick wire. And I started thinking about how I was going to route that, and that's a lot of handwork, and I realized that it's the same handwork on every one. So his sealing bit looks like this. These little widgets. This is a smart splitter at the top, which takes input from this side, preferentially sends it out the sides, and then out the east-west area. So input from the north, and prefers output to the east and west, and any overflow goes out there. So this will build me a manifold where I can take a belt here and feed it in, and a belt here and feed it, and a belt here. This is what is nice about having this 2-level belt scheme where the ground level is all north-south and the high level is all east-west. For the other side, this rightmost output is the output of the control rods. So those all get collected up left to right. And this one is the quick wire, which is too big to be collected up left to right, so he's collected up north and south. So now I need to place 8 of those with 8 of these on top. You can see I already tried to do this once. Ignore this plate, it's really only here so that I can clip to it. So I'm going to put one of these down and verify that everything is correct. Once it's done building, can put in the vertical lifters to feed the inputs down like that. And these all should line up. And our outputs should all line up. And I do want to test this. So before I put down the rest of them, I will pull my inputs around and get them going up here and bring them around and in. I suppose I can get rid of these holes. I didn't even need them. And I don't need glass here. There we go. So that's now a normal ceiling. Oh, and hole. So first of all, I'm going to run the output. This output goes this way. I water it all the way to the edge here. And I'm going to put the next ceiling in just so I can run my output here out this way. And I need to have something in the way of a deck to pull this stuff out to. Well, I can just, I'm going to fake it. So I'll verify this comes up through here to the merger, and this will just go into a sink somewhere. So how close can I get and still be yellow? Well, let's see here. If I do it like this, so we'll be able to see. I don't really need to do a rate test at this point. I just need to see output on the belt. That's long enough. And so our inputs. Our first two inputs, I didn't do any markers up there at all, so I have to do some research. Our first two inputs here are the inputs for the first machines. So we need Caterium ingots and copper ingots on the first two lanes here. So let's find them. Where is my Caterium? So here's the Caterium. We have 3 blueprints making Caterium ingots, which are all sending out that way. So the Caterium I am going to send north. I believe this is my only use of Caterium ingots. So at this point I can reestablish this entire set of things. I want to send it east somewhere in here. Well, that works out neatly because I can just drop my merger in here at altitude. And first of all, this guy goes here. And this guy goes here. I'm spreading them out just a little bit so I don't do too many crazy things with the... I want to bring it out to this line here. Oops. And now we can tear this. Tidy as you go, so tear this line up. And that gives me this going north. So we're going to want to put in some supports. And this is along that lane. So here. And here. I think one more, yes. And he's going to get split and sent further. Okay, so his deal now is he needs to have a splitter to go to this guy. So I'm going to send him down the first row. I believe I have a blueprint for that. No, I don't. Okay. So we'll have to do this manually. Oh, and he really wants to clip onto him, doesn't he? Okay, so we'll have to do it with there. Want a smart splitter on this line, that column, which inputs from the south here, and I'm going to prioritize to the right. But I need to put in a hole down below him. Here. What's going on here? Those should connect. What's going on? Something is weird about this. So that guy goes up. There we go. No. No. Goes down. Did I point him the wrong way? Nope, I didn't. I can't get that to connect. Maybe I have to. Okay, so I'm going to drag belts out of whatever I can. This is going to be a little bit awkward. There's some decision being made about where each belt clips in. Okay, this is why I test these things by doing one of them rather than laying out all 8 and then fighting it. I may indeed need to put these splitters in by hand all along as I build out the belt. That is truly unfortunate. I tell you what, I will use this blueprint, but if I have to clip things out to make my connections, I will do it. Okay, so if I remove the, yeah, okay, so that works. So now I can put this back in. And let's see if that got me going. This is the Caterium supply for the whole set of 8. And I have not hooked up the top yet. And it is not flowing because I haven't programmed it. So any overflow, any. And now we see the Caterium flowing down. So now I need copper. So let's go find my copper line. Thank you, autosave. So here is my copper. So all 4 of these are getting merged to here and going out. So instead of doing this, I want to take the copper from below and merge it with this copper and head it north. Now, can I head it north along this line, or am I using this line for something else? So we're headed east. We've got a bit of a conflict here and a direct conflict there, so we need to head over to the center line of this foundation. And in fact, that will conflict with this guy. So I'm going to bring it over midpoint of this. Yeah, middle point of this. So given that I'm way out here, I missed it. I could in fact pick up the copper from here, and that works out because I have both copper lines coming through, and I can just pick this up and redirect it north, east. So just like that. And there's copper going that way. And I will need the second line of copper also. Now you've got to bring that on that seam. Because the first line of copper will be just for the first 4 machines. So now I need to set up the supports for those lines going north. So the first one is going to be dead center on this lane. Did I say I had to put it on the seam? I hope not. This was the questionable place, I think. Yep, that's clear. So we're good. And the other one's on that seam. Whoops. So there. Gotta watch the perspective when I'm placing these. They have to go on top, not beyond. There. Like I said, I believe this is the ultimate consumer for the rest of my copper. If I need to make the copper go somewhere else as well, I will deal with it then. And this gets out to here. So I don't need the second line of copper quite yet, but I'm going to run it out to make sure I don't use that particular east-west lane for anything else. And he needs to join up with this guy. So face that into there, and we put that in like that, and that's in the wrong place. So it's this, 1, 2. That's easier to count that way. And that was facing the wrong way. So here, 1, 2, there. So I've got copper. So with copper and Caterium both going in, our first machine should start to trigger. Ah, no power. So the habit that I was trying to set up, and I never really did establish, was to be sure always to connect the verticals first, which included connecting vertical to power. Now, these blueprints don't have a power on them, so I have to manually connect it up to that nub, and that nub gets connected out to power in this direction. So 1, 2, 3, here. And generally, these don't have enough connections to allow going crazy too much, but I think this line is good. Oh, and I can, those little plates were to raise the deck during the blueprint making process. They can be peeled off once we put them in place. So you notice now we have a whole bunch of quick wire going into our output at 225 per minute. That should be both machines. And this machine is going to stall quickly because all of his output is going to this machine for input, and he doesn't have any copper sheets yet. Now the copper sheets come in here. On this guy. And just for reference, it's going to be copper sheets and stators. So copper sheets in on this one, which is this lane, which I'm going to run out just like that to our edge, so I know which one it is. So I have 2 lanes of copper ingots that are come north, and I'll just put the copper sheets next to them, which is convenient because that's where it is here. And we only have 1 lane of copper sheets being produced. Well, we actually merged 2 lanes, so we could keep 2 lanes going north, but the quantities are so small. Probably better to take the 1 belt north and put in a splitter. I'm going to prepare the splitter now. The smart splitter goes in on this line here. Programming is the same as here, so we're going to copy the Caterium, copy it in here, and that's correct. And now the lifter. Okay, this is on the right one. And I am putting up with this kind of partial clipping like this because it's the only way we're going to get any kind of close spacing on our belts, which we do need. So now I need to redirect the copper sheets that direction. Easy enough. It is on this seam right here. And it's going to head left. Alignment looks good there. There's our input. So now copper sheets. Yay, copper sheets. I am still getting some hitching of the game. It shouldn't be due to pop-in of terrain. So I am wondering if I should turn off a bit of feature that uploads my gameplay to their test servers. Yeah, I think I'm going to give that a shot. So we're going to go into options. And let's see where to go. Send gameplay data. We're going to turn that off and see if that solves that occasional stop-start we're getting. Network quality. Improved network at the cost of server. I'm going to turn this down to low. Yes. I need to restart the game session for this to work. So I'm going to save the game. We're going to restart the Satisfactory and bring it back up and see if that helps. Pausing. Okay. So I have turned off uploading of game save data, and I've changed the network quality, and we will see what that has done to my frame rate. I'm more worried about sudden pauses where it's not responding to input, but it's still storing it. So for instance, if I move my mouse and it hitches, we've suddenly swung the mouse all the way around. But now we have the copper and the copper sheets, and the copper is being routed in, and down and around. Make sure it gets to the right one in the right place. And indeed, we are producing AI limiters now. The AI limiters should be arriving here. So all we are missing now is the stator input. So stators, here they are. I believe this is my only use of stators in the game. If not, I can come by and pick them up and reroute them. And this will go right here from low to high, turning and outputting to the correct direction. That. And stators will also need to be split, which means I had 2 splits in a row here, which means that this is going to be a little confusing. And we are going to be facing this to the left. And taking from the right. So same program. I'm going to go ahead and put the overflow belt in first so we can see that it doesn't get any until it needs it, or until we have filled the first one. Stators go down and around and in, and when they back up, we will see them appear getting ready for the next group. So we have routed the current backlog of stators, and now we're into normal stator production rates. And we see that we are starting to get rods. So we have our 2 outputs running. Our performance tests will be later. I think I can just use that. I will need to clean this off like crazy. Not too hard to clean off. These little raised mergers and splitters are fairly simple constructions when it comes down to it. There's not a lot of moving parts here. Going to go ahead and run my output out to here. And I will need to choose what I'm doing with my quick wire outputs. I think I'm pretty much just going to need to turn them around and do something. I'm beginning to think that I need to have these facing the other way. And have them merge to the left. Yeah, my top plate may need adjusting. So that the quick wire can be streamed off to the left, or, no, because this still outputs out that way. I do have a basic problem. Let me see where the quick wire is actually going. So the quick wire is used in AI limiters, which we've already got. Uh, 1800 Caterium outpost to nuclear plant. Hold on. Who does need that? Guess I need to bring up my master plan here. Nuclear power, main plan. Nuclear fuel, Caterium outpost. That's interesting. Oh, that's Caterium ingots. I'm sorry, quick wire. So apparently it is used in something called DD2Y, which is nuclear fuel preparation. I should probably show this. This is from my master plan. And there it is. So I need to take all of this quick wire, all 4 belts of it, and it needs to be made available for a late stage in nuclear fuel prep. So I do want 4 lines of quick wire heading off to the north. So what can I do to this plan to make that work? Well, I can turn this around so the quick wire comes down here and have my 4 lanes of quick wire right in here. So let's fix that over on this guy. And I'm going to plan out for quick wire I will just make it midpoint to midpoint here. He will go from south to north. I just want to place these belts to get a size idea of how much space these 4 lines are going to take up. Rather than, they really want to clip to each other, don't they? So if the quick wire is doing that, I just need to turn this guy around. So he needs a merger. I'm going to bring it in on the right and merge it from that direction to that direction. It's just like this. Gives you a little more room to work with. And that means this guy can come out to here. As I place these, I can remove the belts, but having the belts there gives me a line of where I want to put things, which is going to be helpful. The alternative is that I could leave supports in place, but I don't think that's anywhere near as good. So in the first row, we will be taking from here and sending it on that. In the second row, we'll be removing the belts and flying it over. Now the question becomes, do I want to do the same thing with the other output? Bring him in and make 2 lanes of him. This is DD2F. So the second output is electromagnetic control rods, about 70. So we really only have 1 belt of control rods, so I could do the same thing with this and have it merge into that belt. It means that this needs to merge from the north. So let's rework this as well. So same thing here. It's going to come from the north, merging to the south. The difference is that this one is actually going to merge into this line here somewhere. So a merge from the right to the left along that line-ish. And we'll have to remove this from the eastern set. And I'm going to run this belt out to the end here just to show where it is. And as long as I am running belts. Oh, so this is a good use case for the conveyor poles. Boom, boom. Here's our inputs. Here's our wire outputs. So now I should be able to clip in and out like that. This may also solve some of our problems with picking lifters. And on the other end, I'm going to put it right here near the edge for this guy. And just inwards here, since we're only doing this to reserve for these guys. So in theory, when I put all this together, I could clip from these belts to the next one over. Probably not a bad idea. Although if I wanted to limit the number of distinct items placed down, I would then remove the belts and remove the poles and connect them up from end to end. That's a tidying up thing we can do later. So for now, I will just do this. So that's a whole lot of north-south beltage. I am going to connect these guys. Am I going to connect these guys this way? I don't think I'm going to do that. Or can I? this, this is going to be weird, but for the eastern set, I want a belt showing me here where this goes. Like that. Complicated, but I think it'll make it easier to get it hooked up. So the next thing I need to think about is, do I want to use the new deck? I think I do want to use the new deck in place now. In fact, I'm going to take up all of the blueprints. And this is all the crap that I set up manually. So we want to trim it. And we're going to do one more run of these first two from blueprints to test and make sure this works. And I really wish we had not just a pick up the blueprint, but pick up everything in this area. And what is the deal with these? Apparently some of the cases of lifters and such don't completely unbuild. So what I'm going to do, no, I'm not. I'm going to set up some poles here. I think in this case I still want a pole back in by a hitch. It was midway. And I'm not sure where they come out, so I won't put them in yet. I'm going to save and reload and see if those black squares go away. That's really disturbing that that's there. So F5 to save. I thought. Save game. And now I'm just going to load it right back. The engineer in me is curious as to whether those black squares are items Satisfactory is rendering or items that it rendered and didn't unrender. Like if it's kind of a leftover thing. Okay, reloaded. And I don't see the black blotches, so apparently that's something that's left over graphically, but it's not a part that's in game. And I did leave a wall outlet. So we should be completely clean here. We have our supply lines that I previously ran coming in and getting prepared to go toward us. We've got the output for the control rods, and we will add in the outputs for the quick wire when we get them. So first step is the Caterium production line itself and the top part which goes like that. And I'm going to put in the second top part so I can connect it up. And I might as well put in the second Caterium line down below. Okay, let's start trimming things that we can trim. First of all, these nubs can go away. Second thing is that the output lines aren't going to be used on this one. That. Which means this hooks up here. And in fact, I am going to run all the way up here and hook it up with a single belt, and same thing over here. Oh, let's get rid of these two. Okay. Now on this one, it's this guy that isn't used, and this guy that isn't used. What did I mess up? Oh, that's right. So this is our Caterium wire coming down, and he will be turned into one of our output lines. Okay, so let's get our inputs going, and then we can get our outputs going. The inputs are a little fiddly. This is too close. So I'm going to see if I can connect this up. So everything else still set properly. We didn't have to delete anything excessive, just that one little nub. And now we can connect all the rest of these. I believe we have to connect that fresh as well. Okay, so everybody's running to here. I'm going to build the connections on the top as well. So the first line is the Caterium, which I should have routed and did not, which just gets a plain old lifter, which isn't going to go in until I connect something here. It needs to be in line with this guy, like that, and turned and set. Caterium. Second one is the copper ingots, which are on this line. This is all a one-time only connection, so we've got once we connect with a splitter and once we connect direct. In fact, once I've done it now, I never need to do it again, even if I tear down the blueprints. And the rest of these are very similar. And while we are routing things, the next step is to route my Caterium here, which is going to go onto this line. So in that place, like that. I'm going to place these just in case we want to tear up the blueprint again. Okay, so top routing got done. That was the bit I was worried about because we previously had things working. So now we can do power and outputs and inputs. I'm going to do them in that order. Power, we take it up. And we take it over. And I'm going to drag power from here out this way to provide a supply. That will go up here. So everybody's got power. In this case, I'm running the output first. So up, bent through here, merge here, and out there. That's quick wire. And up, and merge to here, and then merge onto here, and that should be the control rods. Okay, now get the inputs done. We're still getting hitching, so apparently it's not just the options that I have been fiddling with. So at some point I will turn back on the option to send my gameplay because I think they benefit from that. And this is experimental, so I do want them to get as much test data as possible so they can fix as many things as possible. Call it professional courtesy from a retired engineer. So now we should have a whole bunch of stuff coming down. I look over here and there's our sheets. And we should start seeing control rods slowly. Yep. So 10 control rods per minute out of each one of the blueprints. I think at this point I'm going to do a checkpoint save and cut the recording because we've got rumbly thunder in the background. I will continue to place these, get the other 6 going. The only real difference is going to be it's going to be simpler to hook up, and the quick wire has to go on different belts. And when we're all done, I will take all 5 of these belts and run them out here and drop them into syncs so we can have the whole thing running quickly. So next recording, I will do a performance check of this and go on to whatever the next thing is. See you then.